Okay, I'm really excited about this problem. I thought it was very clever. This was in the geometric series section, and somebody brought it to me. I don't remember what problem it was, but I think it's really clever, and I want to show you what we figured out. So notice this is not arithmetic nor geometric. Kind of the top is almost an arithmetic sequence, and the bottom is a geometric sequence or series. But together, we don't have any way to show that their sum is equal to 1. But what I noticed is that this becomes 1/4. Well, would you agree that 2/8 would be equal to 1/8 plus 1/8? Okay, so notice that what I can do here is then I can say that this is, well, okay, hang on just a second. I have 1/4 plus 1/8 plus 1/16 plus 1/32 plus, and I can keep going on that series. Well, to get to this 2/8, I have 1/8 plus 1/8. To get to, well, and then I can take this series, and I can keep going. But notice I need 3/16. So what I'm going to need to do is I'm going to need another series that starts with 1/16. Okay, and then it would have 1/32, and then it would keep going and going. Okay, notice, okay, so in this one, a sub 1, our first term is equal to 1/4, our common ratio is 1/2. In this one, our first term is equal to 1/8, our common ratio is 1/2. On this one, a sub 1 is equal to 1/16, our common ratio is still 1/2. And then notice, okay, so I have 3/16 going this way. I have 1, 2, 3. Well, if I need a 4th 32nd, then I could start another series here. And if you think about this, what I can do is I can keep doing this. I can now have an infinite number of infinite series. Excuse me. Okay, so if I want to find the sum of an infinite series, it's a sub 1 over 1 minus r. So that first one was 1/4 divided by 1 minus 1/2. Okay, so if I have 1/4 divided by 1/2, that's equals, sorry, I don't need to write all of this out for you, but that's equal to 1/2. Okay, so this first one, this had a sum of 1/2. An infinite sum. The next one, I said, okay, well, what's 1/8 divided by 1 minus 1/2? Okay, 1/8 times 2 is going to be equal to 1/4. So this one right here had a sum of 1/4. Well, I don't know if we can see the pattern yet, but let's just try. I would expect the next one to have a sum of 1/8. Okay, so it's 1/16 divided by 1 minus 1/2. And 1/16 times 2 is going to give me 1/8. And so now I've got my infinite series had a sum that is now a geometric series in and of itself. Okay, so now I've got a new series. I don't know that this is, the proof is in my words in what I'm saying here. But now I have the series of infinite series, the series of the sums of infinite series. I'm having really a lot of fun saying that. But what happens is this becomes, the first term was 1/2. The common ratio, notice I multiply each of those by 1/2. It's 1 minus 1/2. If I have 1/2 divided by 1/2, that equals 1. Okay, so what you're likely to need to do is you're likely to need to write this up a little more clearly or kind of explain through what was happening. But we broke this down. I would turn this into somewhat of a paragraph proof if they asked me to prove this. You can say that this set right here is equal to the sum of an infinite number of series, and that the sum of each individual series, you found a few of them and you realized that became a geometric series in and of itself, and then you can find the proof, the solution of that. So that, in my opinion, is a clever problem. Enjoy.